Hey AP Calc students, time for more FRQs. This is 2017, number 6 on an old AP Calc AB exam. So if you can read this one here, that's great. Otherwise, go ahead and head to AP Central and head to year 2017, number 6. Now this style of question is what I refer to as a function build. And it's a little bit function build, and you could also say it's a little bit potpourri. It doesn't give you the real-world applications as in a rate that is representing something increasing or decreasing or a velocity or anything like that. It's a fairly straightforward, let me give you a function and use all your math skills to see if you can manipulate it. And let's see what they ask. So to start, it says, let f be the function defined as f of x is equal to cosine of 2x plus e to the sine of x. Kind of a complicated function. Then it says let g be the differentiable function. A table of values is given for g and its derivative g prime. Well, that's this table right here. And then there's a third function, h, and it's not giving you the function, it's not giving you a table of values, it's giving you a graph. So this is testing all of your abilities to manipulate a given function in equation form, manipulate a table of values of another function, and manipulate a graph. Can you elicit all the information that you're going to need? And then there's even more fun where you have to build a function using these three functions. So let's see what they ask for first and how much work we have to do here. So let's look at A. And by the way, since this is the g function here on the table, this is g, here's h, I'm going to go ahead and write f, what the f of x function is here, nice and big, so we can refer to it. So f of x is equal to the cosine of 2x plus e, and e has an exponent of the sine of x. All right? So there are the three given function bits of function information. So letter A says, find the slope of the line tangent to the graph at f. This is just testing your vocabulary. Do you know that a derivative is the slope of a tangent? If you do, this is a very easy question. So what they want to know is give me the slope of the tangent. Well, you should know the slope of a tangent is a derivative, and they're asking it about function f. Well, here's f right here. So I'm just going to take the derivative of f and put it right here, and then evaluate it at x is equal to pi. So we need to figure out f prime of x. Well, f prime of x is equal to the derivative of cosine is going to be the negative sine of 2x times the derivative of the angle, which is 2. And then the derivative of e to the sine of x is going to be itself times the derivative of the sine of x, which is the cosine of x. There's the derivative, and now the question is, can you evaluate it at pi? So I'm going to evaluate f prime at pi, and it's going to test me to see if I know my common locations for the trig values. So if I put pi into here, I get the negative sine of 2 pi times 2 plus e to the sine of pi times the cosine of pi. So if you'd like, you can sketch yourself a little unit circle for reference point here, and we're going to be looking at pi and 2 pi, these two spots here, 0 and 2 pi, and then this is pi. So here we go in our simplifying. So f prime of pi, so sine of 2 pi right here, this is 0. So it looks like this entire term right here simplifies down to 0, plus the sine of pi. Sine of pi over here is also 0, so this is going to be e to the 0, so that's going to simplify down to 1, times the cosine of pi. Well, cosine is the x value, and that's going to be negative 1. So it looks like our answer is just negative 1. So the slope of the tangent, is equal to the derivative at pi, which is equal to negative 1. So there's our answer. Let's move on. B. Now B is where the first function build starts. B gives you a new, or asks for a new function k. And what they want you to do is they say, now we want you to build a new function k. And k is actually h of f of x. And this is function composition, which you should have done in Algebra 2 and Pre-Calc, and this is actually a way of representing the chain rule. And what they're asking us to do is to find k prime of pi. That's what they want. So what we have to recognize here is that this is really just the chain rule. And so with the chain rule, you have to take the derivative of the outside times the derivative of the inside. An example I used earlier would be something like, what if you had the square root of x cubed plus 1? Well, the first thing you would do is you would say, well, that's really x cubed plus 1 to the 1/2. And the first thing you do to find the derivative is you deal with the exterior. You deal with the outside of it, and you just say, what's the derivative of something raised to the 1/2? And you would say, well, 1/2, that's something to the negative 1/2. Well, that part of the function is h. The inside of the function is f. Notice how f of x right here, we haven't done anything yet. But you guys know that you would jump in here, and then you would say times 3x squared. So here is the inside function and its derivative, and the exterior is here, and the exterior function is 1/2 the quantity, the negative 1/2. Well, using this idea, whenever you take function composition, we just deal with the exterior. And we say, oh, well, the derivative of h of f of x is just h prime of f of x, times, now we get to go inside and take the derivative, which is times f prime of x. Chain rule, function composition, same thing. Now we have to evaluate it at pi. So now we need k prime at pi, and we have to take h prime of, well, now here we have to start applying based on what they've given us here. So the first thing they need us to do is to figure out what is f of pi, so we can simplify that, and then this is going to be times f prime of pi. Okay, so let's see here, f of pi. Well, here is our f function right here that I've written, and so I'm actually going to figure out what f of pi is. I'm going to do that right here. I say, well, f of pi is going to be the cosine of 2 pi plus e to the sine of pi. So it looks like the cosine of 2 pi is just 1, plus e to the sine of pi. Well, sine of pi is 0, so this is 1. So it looks like I get 2. So it looks like that part simplified down, we just get 2. So k prime of pi is equal to h prime of 2 times, now we need f prime of pi. Well, that actually, we can just take that answer from the first part. We actually figured out what f prime of pi was, and that was equal to negative 1. Now we're still not done. We now have to figure out what is the h prime of 2. Well, h prime was the graph. So since they're asking for the derivative, or h prime, we need the derivative. Well, this goes back to, do you know that a derivative is the slope of a tangent? So what we're going to do is go to 2 on the graph. So 2 is right here. Well, what is the slope of this function at 2? Well, the instructions here tell us that this graph is made up of 5 line segments. So what we can confidently say is that, well, this is a line segment right here, so if we could get the equation of that line, we could then take the derivative. Well, this equation is really easy. It's linear. Not only is it linear, it goes through the origin. So if you wanted to be really picky, you could say, well, the equation of this little part of the line would actually be y is equal to, now the slope, we fell 1, ran 3. So the slope of that line is negative 1/3. You could say, well, the actual graph that makes that is negative 1/3 x. And the y-intercept is 0 because it goes through the origin. Well, that's the equation of that little line segment. So the derivative of that is just negative 1/3. Or if you prefer, you could say, well, tangents to linear functions is just the line itself. So the slope of the tangent is the slope of the line, because it's a linear function. However you want to look at that, the derivative right here at 2, h prime of 2 is equal to negative 1/3. And so our final answer here, k prime of at pi, this turns into negative 1/3 times negative 1, and our final answer is 1/3. Okay, and just like up here, I want to box that. Might need to come back to that for later. Okay, so A, done. B is done, 1/3. Okay, now it's time for part C. And part C says, let M, so now we have a third function we have to build. So I'm going to come over here, and I'm going to erase some of this work to give us some room to work here. And I'm going to get rid of this part here. And I'm going to leave the actual function written up there. And so for part C, this says, now m is the new function, so here's the new information we're given. M of x is equal to g of negative 2x times h of x. And the question says they want us to find m prime of 2. Well, here's what they're testing on here. We have a product of two functions, and so to take a derivative, we need to know your product rule. That's all it is. So you'd go, all right, well, then the derivative here is the derivative of the first. However you were taught, you know that you have to take the derivative of each one individually times the other in a sum. So I like to take the derivative of the first, which would be g prime of negative 2x, times the derivative of the inside, which would be negative 2. So there's the derivative of the first, times the second, h of x, plus the first, which is just g of negative 2x, times the derivative of the second, which would then be h prime of x. So the first is here, and so there's the derivative of the first. Here is the second, and so there's the derivative of the second. And so the second was not affected here, and the first stayed itself there. So now we have to evaluate that at 2, and we're probably going to have to now start using all the either the table or the graph or the function for what these are. So let's see what we get. M prime of 2, if we put 2 in here, we get g prime of negative 4, and then we just still have this negative 2 sitting there. H of 2 plus g of negative 4 times h prime of 2. All right. So now, let's see if we can simplify here. So now I have m prime of 2. Let's see what we can do. Well, the g values are now the table, so we can go to there and get those. So g prime of negative 4, my x value is negative 4, g prime is negative 1. So that's the value I get there. So I get negative 1 times, this negative 2 has just been hanging out there the whole time, times h of 2. Well, now, if you remember back over here, we were dealing with h prime of 2 right there. In the function, I got negative 1/3, but this is saying h of 2. So if this is the graph of h, all we have to do is just go to 2. Well, at 2, we would drop down to negative 2/3. 2 times negative 1/3 is negative 2/3. So seems a bit weird, but it is a fraction value. Okay, and now g of negative 4. We're back to the chart, and we say g of negative 4, that's the g column, so that's going to give us 5. And then now it's h prime of 2. Now remember, the primes are switching here because we're doing the product rule. So h prime of 2, that was the derivative there that we used over here, and that's going to be negative 1/3. So I think we can finally clean this up, and we can say, all right, m prime at 2 is equal to negative times negative times negative is a negative, and it looks like we get negative 4/3. And then we get minus 5/3. And that is negative 9/3, which would be negative 3. And that's what m prime of 2 was equal to. Got a little meter there. Okay, so there's C. So we had two function builds. We had to build K and build M using all of our skills there. Now the final step, it's D. I'm going to put D right there. Now D says, is there a number C in the closed interval, negative 5 to 3, such that the derivative is equal to, at C is equal to negative 4? Now this is just code, and if you can pick through there and realize it, and this is the benefit of doing multiple old AP exams, this is just a mean value theorem question. And what it's actually saying is the average rate of change from negative 5 to negative 3, is there a point in that interval that the instantaneous rate of change is negative 4? And from earlier in the year, I'm just going to sketch this graph. This is what this, and I'm going to erase this. But this is going back to an old theorem earlier in the year, that if you ever have an interval, and I'm going to call this interval A to B, and you want to find the slope of the secant. So I'm going to say m sub sec. So this is just notes that this is not necessary for this problem. I just want to review the concept. And this y value would be f of A, and this would be f of b. Well, the mean value theorem says, find the slope of the secant. And if we did that, we would say, oh, well, the slope of the secant, this is algebra 1, we would say, oh, that's f of b, minus f of a all over b minus a. Easy, get the slope of the secant. The mean value theorem says that if the function going through here is continuous and differentiable, then here's what we know. There is some point in the interval such that the derivative at some c value, remember a derivative is the slope of a tangent, will be equal to the slope of the secant. And so if I just sort of estimate it here, it looks like that's kind of close. This would be my tangent right there. And that would be occurring at this c value. So the mean value theorem says if a function is continuous and differentiable on the closed interval, a to b, there exists a c value in the interval such that the derivative at that c value, or the slope of the tangent, is equal to the slope of the secant, or the average rate of change over the interval. And so the way you would write that on this one would be f prime of c. So everyone, this is the mean value theorem. Okay, so AP is in love with the intermediate value theorem and the mean value theorem, and this is what this one is. Okay, so is there a point where the I rock is equal to the A rock? There's several ways to say it. I rock equaling A rock is the slope of the secant, the same as the slope of the tangent. And the way they set it up here is they were kind of vague, and they just said, is there a number in the interval so that g prime of c is equal to -4? And it's just a matter of seeing this enough times where you just go, oh, there's a mean value theorem question. So I'm going to erase that, and I'm just going to do this, and we're going to see. So what we're going to do is just take what they gave us, which was on the interval -5 to 3. Okay, so there's the closed interval. We want to figure out what is the average rate of change over that interval, and the question is there a point in there where g prime of c is equal to -4? So here is the question. So what we're going to do is we're going to find average rate of change, slope of the secant at this value right here. So we would say, okay, well, the slope of the secant, which is equal to my average rate of change, and this is not necessary to write. I'm just putting in there for, well-rounded understanding. But what is necessary to write is for you to go here and say, all right, it's the g function here. So I'm going to say g of -5 minus g of -3 all over -5 minus -3. Now it's the g function which puts us back onto the chart, or the table of values. And so now we can just look. G of -5 according to the table is equal to 10, and g of -3 is equal to 2. And then below here, -5 minus -3, that would equal -2. So we get 8 over -2, and that is -4. So the slope of the secant, or the average rate of change, is -4. And what's it's asking you, is there a value in the interval such that is there a c value in there such that the derivative, or the instantaneous rate of change, or the slope of the tangent is -4? Well, look at that. The average rate of change was -4, so yes. So what we would say is, we'd actually answer the question, yes. There is a c value, -5 less than c less than -3. That's a c right there. There is a c value in the interval -5 to 3 such that g prime of 4, g prime of c is equal to -4. G prime of c is equal to -4. And so the fact that you're writing the statement here, yes, there is a value such that there is a c value in the interval -5 to 3 such that g prime of c is equal to 4 by the mean value theorem. And what's also justifying your work here, this is critical that you have this. So you have to show the slope of the secant, or the average rate of change here. That has to be shown. And then your statement. You got -4 here, and there's the question. So yes, there is a c value in the interval such that that is true by the mean value theorem, and communicates that you know what you're doing. Okay? So again, function build 2017 number 6. There it is. See you next time.